on probability of an event. Now, I believe that you still remember the definition of probability. Now, just to remind ourselves, let me give you the classical, I would say the classical definition of probability, which is simply the ratio of the favorable outcomes to the total possible outcomes. So that's the classical definition. The value of the probability is between 0 and 1. So when we talk of zero probability, the interpretation is that the event will not possibly occur, while if the probability is 1 or 100%, it means that the event will surely occur. That's how we interpret the values of probability. In the board examination, you are interested of determining the probability of an event. And later on, I'll give you some examples on how this particular topic can be given in the board examination. Let's try to understand also some formulas that we will use later. If we consider two events, in this case, event A and event B, and it should happen that the two events are not mutually exclusive, meaning there is an intersection of the two events. So there is a common space of the two events. If you are interested of the probability A union, A union B, because we are talking here of union of two events, the probability A union B means the probability of A is one here, this event, what is its probability, plus the probability B. And if you notice, you are now double counting the intersection of the two events. So you have to subtract one of it. So the formula is now probability A union B equals probability A plus probability B minus the probability of the intersection of the two events, or the probability of this particular space. If A and B are mutually exclusive, meaning one is not affected by the other, exclusive. So B has nothing to do with A, at the same time A has nothing to do with B. So it can be represented in this manner. You have here event A and event B. And as you can see, they can occur without one affecting the other. Then the probability A union B is simply probability A plus probability B. In the actual problem solving later, when we talk of union, the connective OR is used. Say, for example, what is the probability of A or B? Word OR. That's union of two events. Now, conditional, the conditional probability of a particular event. What do I mean by this? The conditional probability B given A, which we write it in this manner, PBA. So you say probability B given A. That's how to read it. This symbol, I repeat, is read probability B given A. It is defined as the probability of A intersection B divided by the probability of A. That means the probability B given A is the ratio of the probability of the intersection of the two events to the probability of the reference event. So probability B with respect, not with respect to A. And this is true, this formula is only applicable if A, probability A is not zero. Because, of course, in mathematics, if you divide a number by zero, it is indeterminate. Okay, next is, if you can see this diagram, so you have here probability A or event A, and this is event B, and this is the probability of B given A. Given A. So what you need to do is simply divide this particular intersection by the entire event A. That is probability B given A. If the events are independent, you can see independent events, then the probability B given A is just the same as the probability of B. Because A is actually not affecting B this time. Or probability A given B is just equal to the probability of A. If A and B can both occur, so this is now multiplicative rule. No? A and B can both occur. So the connective used here in the problems later on is the connective and, not or but and. No? A and B are or can both occur, then the probability A intersection B is the probability A times the probability B given A. That's how to obtain the probability of A intersection B, which is actually similar to this formula, except that you are rewriting it, no? Instead of solving for probability B given A, you are now solving from the probability A intersection B, which is just the same as the probability B intersection A, which is the same as the probability B given A times the probability of A. Okay, so A intersection B is the same as the probability A times the probability of B given A. If the two events are independent, then the probability of A intersection B is probability A times probability B. And let me give you these examples. So we have here an example. A box contains 20 marbles, of which 5 are red, 15 are blue. So 5 and 15, that's a total of 20. 2 marbles are selected at random and removed from the box in succession without replacing the first. So you take the first, do not put it back, then get the second. Question is, what is the probability that both marbles are red? Now, in this particular case, you can use the multiplicative property, no? Probability R1 and R2. Probability red 1 and red number 2. The probability of obtaining a red marble, probability of getting a red marble in the first draw is 5 over 20 based on the classical definition where this is the figurable. So if you will get one marble, the figurable outcome that it is red equals 5 because there are 5 red marbles in the box divided by the total possibility. And because there are 20 marbles, so there are 20 possible or 20 total possible outcomes. In the next draw, the probability of getting another red would be 4 because one red ball has been removed already. So there are four red marbles left. And in total, because you don't replace the first marble, therefore there are 19 marbles left. So in this case, 5 over 20, uh, multiply it by 4 over 19. Or the result is 1 over 19 now, because you can just make that 4, and then 4 and 4 will cancel. Sometimes the problem, so the method of solving it similar, what I mean, the interpretation is similar, but it can also be stated in this manner. The box contains 20 marbles, of which 5 are red and 15 are blue. If 2 marbles are selected at random, take note, you take 2 marbles and you select it at random. The question is, what is the probability that both marbles are red? So the symbol would be probability of getting 2 red marbles. And the classical definition says favorable outcome, you divide by the total possible outcome. That's according to the definition of probability. And the favorable outcome, because there are 5 marbles, I can list down the favorable outcomes now. So this is red number 1, red number 2, red number 3, red number 4, and finally, red number 5. So what are the favorable outcomes? If you take 2 marbles and the favorable outcome is both marbles are red, then we count this as one possibility. Okay, so this is one possibility. That's 1. This is another possibility. That's 2 already. Third possibility, and then fourth possibility. Now take note, the outcome of 1 is different from outcome of 2 and 3 or 4. So there are, in this case, there are already 4 favorable outcomes. But this one is also favorable. Red 2 and red 3. This is also favorable. And this one is favorable. So we have now 7. So 1, 2, 3, 4, so 5, 6, and 7. Well, take note, this is also favorable. See, and this one is also favorable. That is 9 already. And this one is also favorable. So in total, there are 10 possible outcomes. 10 possible outcomes. You can also calculate it directly. You don't have to do it one by one and list the possible outcomes. So we have there 5 combined 2. The result is also 10. So instead of counting it one by one, you just apply the principle of counting. In the principle of counting, this is combination, where you have 5 objects, because there are 5 red marbles, and you take 2, and you are interested of 2 red marbles. The total possible outcome is calculated also as 20 combined 2. There are 20 marbles in the box, so if you get 2 marbles, then there are 20 combined 2 possibilities or different ways of getting these marbles. A total of 190. So if you are going to perform, you can just remove the 0 and you get still the same result, 1 over 19. Any question so far at this point in time? Okay, so at the down it checked. At the moment there are 51. So others probably will just uh, follow the recorded version of this lecture. Okay, let me check on JC James Chua. JC James, are you there? JC? Okay. Any questions so far, JC? Okay, no question from JC. How about Ayan Xian de Los Santos? Ayan Xian. Okay, none, sir. How about Binsig? Binsig Isron?
No, sir.
Yes. You have any question or clarification?
None, sir.
Okay. Thank you. So let's move on. Here is a problem of conditional probability. The probability that regularly scheduled flights departs on time is 0.84. So that is the probability that the flight departs on time. The probability that it arrives on time is 0.81. You see the chance of arriving on time given that you departed on time is not the same as the probability of departing on time, no? So probability of departing on time is 0.84 and the probability that it arrives on time is 0.81. And the probability that it departs and arrives on time, so we call it now PD given PD intersection A. That's the probability that it departs and arrives on time. So take note of the connective and departs, and so we use the intersection symbol 0.79. Question is to find the probability that a plane, letter I, arrives on time given that it departed on time. Meaning, what is the probability A given D? So this one is read as probability that it arrives on time given that it departed on time. The number two, what is the probability that it departed on time given that it has arrived on time? So this is now the probability that it departed on time given that it arrives on time. Probability D given A. So for letter I, we solve it as the probability D intersection A divided by probability D, which is just a matter of substituting values. The result is 0.9405. The probability D given A, it's the same as probability D intersection A, but you divide it by the probability of A, where the probability of A is 0.81. So the result is now 0.79 divided by 0.81 or 0.9753. So, conditional, no? That's conditional probability. There's another problem on probability. A box contains 20 marbles. I think let me check what's the difference of this to the first problem. Here, 5 are red and 15 are blue. If two marbles are selected at random, so remove from the box in succession without replacing the first. What is the probability that one is red and the other is blue? So this is a case where you need one red and one blue marble. You can also write the symbol to this is probability red, na, then followed by blue. So probability blue. Now, this expression is interpreted as in the first draw, you get red marble, and in the second, you get the blue marble. So I would say PR1, PB1. But it's also, no? It's also a possibility that the first draw is a blue marble and the second is red. So there is now a connective OR. I would say probability that the first one is red followed by blue, or the probability blue. I just label this as 2 PB2 so that it's not, no, it's differentiated from PB1. Then followed by red. So probability red number 2. So how do we solve for P red number 1? Take note there are 5. So 5 red. Then I will divide this by 20. So that's probability of getting a red marble in the first draw. Then the probability blue, since there are 15, but this time only 19 marbles left because one marble has been removed. So that is the probability of red 1 and probability blue 1. But I mentioned earlier, there's a connective OR, so you have to add. The probability of obtaining blue marble in the first draw is 15 divided by 20. Then you multiply it, followed by red, where red is 5. Then you divide it also by, 19, because from the 20, you already get one marble. That means there are 19 marbles left. If you are going to simplify this, let me check now. This one here will become 4. So we have 15, then 4, 19. Here, 15 and 20. So this one will also become 4. That means the result would be 15 over 4, then 19, and multiply everything by 2. This one, you simplify. So the result is now equal to 4 and 2 will become 2, and 15, this is 19. Therefore, the result is 15 over 38. So this is the answer. No? If you are going to solve it in this manner, probability red in the first draw, followed by blue in the second draw, or probability blue in the first draw, followed by red in the second draw. Now, you can also solve it in this manner. No? Take note, there are 5 red, and there are 20 blue. So there are so many of them. Because I will emphasize this to you. What will happen if you just list down the different possible outcomes? Now in this illustration, this is red and this is blue. So the favorable outcome would be 1 red, 1 blue. So it could be this one partnered with this blue marble, or maybe this one and this one and that, this one and this. There are so many, no? There are so many possibilities. Or you can also calculate it in this manner, because we are interested of 1 red and 1 blue. So you can also calculate the favorable outcome as multiplication, knowing that there are 5 red and 15 blue. And the total possible outcome, because you are hitting two marbles from the box, so 20 combined 2. And the result is 75 over 190. It's the same as 15 over 38, similar to the calculation that we obtained earlier. Okay, at this stage, I would like to pause for a while and entertain questions if there are questions or clarifications. Okay, none so far. So let's continue. This time, I hope you're familiar with playing cards, because if you haven't played cards, then problems like this is difficult to solve. No? So I encourage you to play cards from sometimes. Suppose 3 cards are drawn from a deck of 52 cards. So one playing card has 52 cards all in all. 13 in a suit, no? So there are 4 kinds, by the way. We have heart, diamond, club, and spade, no? And for each kind, there are 13 cards from ace up to king. So we have ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there are 3 face cards, the jack, the queen, and the king. Okay, suppose you are drawing 3 cards, or you are given 3 cards from a deck of 52 cards. Now, what is the probability that all 3 of them are diamond? So 3 diamond. How do we compute this? First, again, we use the classical definition, where classical definition is simply the favorable outcome. You divide it by the total possible outcome. And the favorable outcome, you just get the combination of 13 diamonds, combine 3 at a time. There are 13, and you combine 3 at a time. Okay, so the total is 286. So if I'm going to, let me demonstrate it here. So if you consider the kind diamond, so you start with ace, number 2, number 3, 4, 5, 6, 7, 8, 9, and 10. So these are the cards. And then you have the face cards, the jack, the queen, and the king. So in total, 13. And you are going to take 3 cards. So 3 cards, it might be this one and that. So this is one possibility. But this is also another possibility. Okay, that's 2 already, another one, and so on. So you can imagine that there are 286 favorable outcomes. There are 286 different ways of choosing 3 diamond cards from a deck of playing cards. And the number of possibilities, since there are 52 cards all in all, you just say 52 combined 3. And the result is 22,100. Simplifying it, the favorable outcome is 286. Total possible outcome is 22,100. So the result is 11 divided by 850. So that is the chance that you will get 3 diamond cards. Okay, a card is drawn from a deck of playing cards. Uh, we have answered that problem already. Okay, if I will I will vary the problem a little bit. Suppose I would say three cards are drawn from a deck of playing cards. What is the probability that all three are of the same kind? So how do we attack that kind of problem? All three are of the same kind. Let me check if we can give answer to that. No? So again, let's answer the question. Suppose you are given three cards or drawn three cards from a deck of 52 playing cards. What is the probability that all three are of the same kind? Meaning, if it is heart, then the three cards are all hearts. Then diamond, it should be three diamond, could be three clubs or three spade. What's the result? Anybody can just type the answer in the chat box. What is the probability that all are of the same kind or the three cards are of the same kind? I'm waiting for you to type your answers at chat box. Once again, suppose three cards are drawn from a deck of 52 cards. What is the probability that all three are of the same kind? From Marion, it's 22 over 4 to 5. From Anne Feliz, 22 over 4 to 5. Okay, thank you for those answers. Yes, the answers are correct. 22 over 4 to 5. So take note, no, that the question can be varied a bit and make sure that you understand the situation. Okay, so the result is simply this one, multiply it by 4. 11 over 850, multiply it by 4. Okay, what about this? A card is drawn from a deck of playing cards. What is the probability of drawing an ace or red card from a deck of playing cards? You get one card. What is the probability of drawing an ace or red card from a deck of playing cards? Okay, can you try to answer this very quickly? And then again, you can type your answers sa chat box. You are uh, drawing a card from a deck of playing cards. What is the probability of drawing an ace or red card from a deck of playing cards? Please type your answers at chat box. From Marion, it's 29 over 52. No? Ray Marion Veloso. From Feliz, 7 over 13. Okay, how about the others? From Regalado, 28 over 52. Okay, so let me show you the solution from Clarkin. It's okay. So this is the result. You would say probability is or, no, or red. So plus probability red. But there's an intersection. The intersection is ace of hearts and ace of diamond. Red cards, no? Ace of hearts and ace of diamond. So there are four aces. You divide it by 52. There are 26 red cards out of 52. But there are two common cards, the ace of hearts and the ace of diamonds over 52. So the result is 28 over 52, or you can round it, or you can simplify it further to 7 over 13. Okay, so the answer of Angelis is okay. The answer of Margaret is also okay, but then should be simplified. Clark Kent is also okay, 7 over 13. Thank you so much for the participation. Okay, let's try to analyze this. In a college playoff game, a player was fouled at the act of shooting at the final buzzer. Okay, and you know when you are fouled, when a player is fouled at the act of shooting, he will be given 2 free throws. With his team down by 1 point. So very thrilling ning a game, no? Siguro ang usa ka team is 99 ang score. Yeah. The other one is down man sila o 1 point. Siguro the other team is 100. Unya now ni act of shooting ang usa ka player ini nga team. Butang ka lang A, unya team B, no? Team A, team B, unya ang team A 99 while the other team has 100, pero i-foul ang player sa A at the act of shooting. And ang na-foul nga player has this statistic. The free throw average is 0.75. That's the free throw average of the player, meaning 75% of the time he can convert the free throw into a point. Find the probability that letter A, his team wins. So what the interpretation is, what is the probability that the 2 free throws are converted, meaning counted, na-shoot niya ang 2 free throws. Okay, letter B, the game extends to overtime, meaning only 1 free throw is converted. The other misses, no? But the other one makes it to the basket. Okay, sige, could you try answering that also, and let me check. You just type your answers. Okay. Si Marion typed it already, 9 over 16, and letter B, 3 over 8 for Marion Veloso. How about the others? Okay, the others are not sharing their answers, so let me just discuss this. Okay, so 9 over 16 and 3 over 16. Okay, this is how we solve the problem. For letter A, for the team to win, the first toss or the first free throw is converted, and the second is also converted. So you would say 0.75 times 0.75, because you will say the probability that the player will shot the ball, so 0.75, yeah, 0.75. That's 0.5625. In fraction, that's equivalent to 9 over 16. That's okay, no? 9 over 16. The second one, we will do it this way. The first is converted, no? The second is missed. So, usara man ka point ang kinahanglan to make it to extend it to overtime. But this is also possible to happen. The first one is missed, but the second one is converted. And you do it this way, 0.75 times 0.25 plus 0.25 times 0.75, or in total, that is 0.375. Okay? So the answer, okay, Marion's answer is 3/8. That's correct. 0.375. Thank you. Okay, how about this problem? This is a common problem sa board examination. A box contains 20 pens, of which 4 are defective. 4 are defective. A boy gets 5 of these pens from the box. What is the probability that exactly two are defective pens? What is the probability that at least 2 defective pens have been taken? I want you to consider that the term exactly and at least. For letter A, what is the probability that exactly 2 defective pens have been taken? And letter B, what is the probability that at least 2 defective pens have been taken? Any contribution? Again, you can type your answer if you figure out how to solve the problem. Okay. Well, this is how we solve the problem for number 1, or letter A, we consider x as the random variable, letting or representing 2 or representing defective items. Now take note, there are 4 defective, and the boy gets 5 pens. The probability that exactly 2 are defective, we just say x equals 2, where x represents the defective pens. Take note, there are 4 defective pens, 1, 2, 3, and 4. We consider this to be defective. And the other pens are good. So these are the good pens, no? And there are 15 of them. 16. Okay, so and so on. So there are 16 good pens. Since we are getting 5 and we are only interested of 2 defective, so it might be that this one, yeah, partnered with this. Okay, so this is favorable because there are 5 and then 2 are exactly defective. Or it might be that this pen together with this, yeah, partnered it with this 3. So the idea now is, how many ways could you choose 2 out of 4? 2 out of 4. That's why we have this formula. This will answer the question, there are how many ways by which we could get 2 out of 4. And because we will partner it with another group consisting of 5, where there are 16 non-defective, we choose 3 of them and combine it, no, to the 4 combined 2. So we solve it in this manner. 4 combined 2, 16 combined 3, you multiply them, and then you divide it by 20 combined 5. Because all in all, you will be getting 5 pens. And this is exactly, not exactly. When you say at least, two defective, at least two defective, meaning to say x equals 2 because it says at least 2, x equals 3, x equals 4. And x equals 5 is not possible because there are only 4 defective pens. Therefore, you have to calculate the probability of getting exactly 2, the probability of getting exactly 3, the probability of getting exactly 4 defective pens, and then you add, because if this is happening, this one is not. That's why we use the connective or, no? It could be that x equals 2 or x equals 3 or x equals 4. So you add them. So when you add, you use the word summation. Summation. Then you just, with the help of your calculator, you just say 4 combined x, where x varies from 2 to 4. No, x varies from 2 to 4. Multiply it by 16, combine 5 minus x. So if x is 2, then you need 3 more pens from the non-defective group. If x is 3, then you need 2 more from the non-defective. And when x is 4, you need only 1 from the non-defective. So this is how to do it in the numerator. Don't forget the summation symbol. Then 20 combine 5 in the denominator. I hope you get this one. The result is 0.2487. That is at most, or rather at least, 2 defective. If I will change it to at most, no? Suppose the question says at most 4 defective pens. So when you say at most 4, meaning it includes x equals 4, x equals 3, x equals 2, x equals 1, and common mistake, the x equal to 0 is forgotten. You have to include x equal to 0 and plus x equals 1 plus, or x equals 3, 2, 3, and 4. If the question would say at most 4 defective pens. Any question or clarification so far? Because if you have no more questions, then we'll proceed to probability distributions. So in the probability distributions, the common probability distributions that would come out, ang normal, no? Normal distribution, Poisson distribution, and then binomial. Ano yung mga common, no? Binomial, Poisson, and normal distribution. The other distributions like mga complicated one, kung mga dumbbell, which you encounter probably sa inyong hydrology, ang mga extreme value type 1, that's dumbbell, mga log person, di na kaya na siya mo gawa sa board examination. Okay, so we'll proceed to probability distributions. We'll start with the uniform distribution. Now, when we talk of uniform distribution, as you can see, the probability of the different events equal, no? Because it's the uniform distribution. So a good example, if you roll a die, okay, a die has 6 faces, and if you roll a die, the probability of obtaining 1 is 1/6. The probability of obtaining a 2 is 1/6. The probability of obtaining a 3 is 1/6, and so on. The probability of obtaining a 6 is also 1/6. So this is uniform distribution. Of course, for the uniform distribution, if you will be asked what is the mean, it refers to this quantity. No? That's the center of the distribution. So this is how we do it. The probability xk is 1 over k. So as a good example, if you roll a die, there are 6 outcomes, and then each outcome have equal chance of occurrence. So the probability is 1 over k. Okay, for the mean and the variance of the uniform distribution, so the mean is simply 1 over k, then get the summation of xi. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. Then the variance symbolized by this sigma squared is 1 over k times the sum of the squared. We call this as the sum of the squared deviation. Hello, okay. We are getting the difference between the value of the measurement from the mean, or the value of the random variable from the mean. So this is what we call deviation. And because you square it, we call it squared deviation. And since you are summing it up, so we call it the sum of the squared deviation. Next is, let's familiarize the Bernoulli process. So what is this process all about? The Bernoulli process consists of an experiment that is repeated in times, n times. And then each trial results in an outcome that may be classified as a success or a failure. Take note, for each uh, trial, the outcomes could be classified as success or a failure. So for example, if you are going to answer a multiple choice question, and then there are 4 choices, of which only one is correct, then if you choose the probability of getting a correct answer, if you choose correct as the success, is calculated as 1/4. So this is now the probability of success. If the success is defined as correct answer, choosing the correct answer. But if the success that you are referring to is the probability of choosing a wrong answer, then the probability of success, where success is defined as wrong answer, then it should be calculated as 3 over 4. So that's probability of success. Now, if the probability of success is given as P, then the probability of failure, Q, is calculated as 1 minus P. Muna ang probability of failure. Again, muna yung probability of success. In the Bernoulli process, the repeated trials will be classified, the outcome rather of the different trials will be classified as success or a failure. The probability of success remains constant from trial to trial. Okay, and the repeated trials are independent, meaning the first trial will not influence the result of the second trial or the third trial, and so on. Each trial, is independent from the other. Okay, that's the Bernoulli process. Now, the Bernoulli process will be used in the binomial distribution. So the binomial distribution says a Bernoulli trial can result in a success with probability P, and a failure with probability Q, which is calculated as 1 minus P. Then the probability distribution of a binomial random variable X, that is the number of successes and n independent trials is calculated by this expression. N combined x. This symbol is the same as N CR, where R equals X. Then you multiply it by the probability of success to the power number of successes. Then probability of failure, number of trials minus the number of successes. So this one represents the number of failures. Diba? This is, I repeat, binomial distribution where X could be 0, 1, 2, up to N. Good. Any questions so far as binomial distribution is concerned? Wala ra? Okay ra? Kung tanaw si John de la Serna. Steven. John Steven, are you there? Hello, John. Hi, John. Ay, wala man si John. Narita ni Kim Regalado. Kim, na question, Kim, or clarification?
Wala ra, sir.
Okay, so I believe binomial distribution is well understood. How about si Maria Bacalia?
No questions, yes, sir.
No question ra si Bacalia. Si Blano, Renz?
Sir, no question now.
No question, Renz?
Yes, sir. Wala pa.
Okay. Wa na lang. Anyway, that's binomial, no? And let me illustrate the binomial distribution as follows. If you consider an experiment which is tossing a fair coin 3 times, you toss it 3 times. And then you consider head as the success. Tail is failure because there are only 2 outcomes if you toss a coin, head or tail. So if you consider head as success, then tail is considered as failure. The probability for each of the possible outcomes is presented as follows. If you are interested of 3 failures, because head here is considered success, no? Unya ang tails mao may failure. The probability of obtaining 0 success means all the tosses give tail. So 0 head. What is the probability? The probability is 1/8. Why? Because of the 8 outcomes, how many mga outcomes ta, no? 1, 2, 3, 4, 5, 6, 7, 8. So of the 8 outcomes, there's here only 1 outcome that gives us 0 head, 0 success. If we would say the value of x, where x represents the number of heads, is 1, then there are 3 outcomes. And these outcomes are the tail, head, the tail, head, tail, or the head, tail. So, in total, there are 3 favorable outcomes out of 8. Therefore, the probability is 3/8. The probability of obtaining 2 heads, where heads again is considered success, so the number of successes 2, meaning 2 heads, is also 3/8. Okay, head, tail, head, then tail, head. And 3 successes, meaning 3 heads, 1/8 because there's only 1 outcome out of 8. If you are going to answer this using the binomial distribution, then the binomial distribution, you would say the probability x equals 2, meaning we are interested of this value. It is calculated as 3, no? The number of trials, in this case, there are 3 trials because you toss the coin 3 times. So you would say 3 and combine 2 because you are interested of 2 successes. Multiply it by the probability of success. Means to say the probability of obtaining a head is 1/2 raised to the power 2. Then the probability of failure, that's the probability of obtaining a tail, is also 1/2 raised to the power 1. And this will give you 3/8. You don't have to really count it one by one. You don't have to list all the possible outcomes. If you understand the formula, you can just rewrite the formula. 3 combined 2, no? 3 combined 2, you have 1, 2, and 3. 3 combined 2 means 1, 2, and 3. So 3. This will give us 3. So 3, 2 square is 4 times 2 is 8. So 3/8. That's binomial distribution. So it's repeated here. Again, this symbol means 3 combined 2, no? Kana nga symbol, that's the same in the calculator as 3 combined 2. Okay, I got this problem from the book by Crosio, problem 17, page 286. In a test, there are 10 multiple choice questions. I think this is familiar to all of us, no? Multiple choice quiz on 10 questions, all in all. For each, there is a choice of 4 answers, and only one of which is correct. A student guesses each of the answers. Question is, find the probability of getting exactly 7 correct answers. Number 2, find the probability that he gets more than 7 correct answers. Number 3, find the probability that he passes the test if over half marks is needed to pass. Over half mark, meaning 6, 7, 8, 9, 10 na scores may considered nga passing. Now, each question carries equal weights. Okay, so for number 1, since there are 10 numbers, we have 1, 2, 3, 4, and so on. And here you have the choices. Say A for number 1, A, B, C, D. There are 4, no? Only one is correct. The same also with the other numbers. And now the student did not study, so he just guessed the answer. What is the chance that he will get exactly 7? The idea here is that you can say the student got the first 7 as correct. Then the rest wrong. Fine. It's also possible that number 1 is correct, 2 correct, 3, and so on. Number 7 is wrong. Number 8 is correct. 9 is wrong. 10 is wrong. That's also a possibility, no? So we satisfy the requirement 7, exactly 7 correct answers. Or it might be this one correct, 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 and so on. This is wrong. This is correct. This is correct, wrong, and wrong. So the pattern says there are 3 mistakes and there are 7 correct answers. That means the probability of success, if we consider success as choosing a correct answer, this is 1/4. And choosing a wrong answer, Q, this is now the failure, is 3/4. Take note, the sum of these two probabilities equals 1. Question is, there are how many ways by which a student could choose 7 out of 10 and make those 7 items correct. Therefore, if we are going to answer it for 7 exactly correct answers, we would say the probability of the binomial random variable x equals 7. So x equals 7. We use the formula 10 combined 7. This will answer the question, there are how many ways of choosing 7 out of 10? And there are 10 combined 7 different ways. 10 combined 7 different ways. Or that will give us, if you use the calculator, 10 combined 7. That will give you 120. No? So there are 120 different ways. And what shall we do with the 7 items? 7 successes? The probability of obtaining a correct answer is 0.25 to the power 7. This is the probability of getting a wrong answer. And there are 3 wrong answers. That means the probability is 0.00309. I can also emphasize that indeed, if there are 10 items, you do not study because you just guess the answer, then the chance that you will pass is only 0.3%. The chance that you will get exactly 7 is only 0.3%. Very, very low. No? So it's better to study before taking the exam. Now, the second is greater than 7. No, greater than 7. When you say greater than 7, you answer it in this manner. And ingon man ang question, there is a number to find the probability that he gets more than 7. More than 7 meaning 8, 9, and 10. No? 8, 9, and 10. So, you can utilize the formula 10 combine 8. Yeah, there 1/4. This is the probability of success to the power 8. Yeah, plus 10 combine 9. So here you have 9 correct answers. Yeah, sorry, kuwangan pa nig 3/4 to the power 2. Kanya plus 10 combined 9, then 1/4 power 9. Yeah, times 3/4 power 1. So this is the probability of getting exactly 9. And this is the probability of getting exactly 10 correct answers. Perfect. Now, perfect score. So 1/4 power 10. And then 3/4 power 0. There's no failure. But 3/4 power 0 is 1. You sum them up. So this will give you the probability random variable greater than, the value of the random variable is greater than 7. You can also do it in this manner. No? 1 minus probability x equal to 7. Kini siya less than or equal. Less than or equal to 7. Because it is less than or equal to 7, then in the calculator, you just say 10 combined x, where x is variable that varies from 0 to 7. Then here, 0.25, 0.75, 10 minus x. Now, I have presented here a calculation sa calculator, no? You will be getting this quantity. So that is the summation x equal to 0 up to 7, then 10 combined x, 0.25 power x times 0.75 power 10 minus x. You will be getting the same result, no, of 0.004 if you will follow this formula. Questions, clarifications so far? Okay, and I guess it's time already. It's 4:31. So I will end the discussion up to here. You can go over the solution for the question number 3, and probably you can also study in advance the other probability distributions. That's it that I can share to you today. You can leave the meeting now. So let me turn off
Excuse
the
me, sir.
recording. Yes, please.
Pwede ko magpabili na ako i-ask nimo
Yes.
about other subjects?
No, no problem.
Okay.
The others, you may leave the meeting now.
Pwede po magpabilin, sir. Nasa niya.
Kinsa man to palihaw, si
Bakalya, sir.
Bakalya, okay. Sige,
Thank you, sir.
no problem.
Sir, mangayot day ko link sa recorded nga class for this subject as well as flood control na class.
Wala ba na-post na ko? Marag na-post na ko sa kuan ko. Nasa
Naara to'y usa ka recorded nga na post sa kani nga class.
sa kuan review.
For fundamentals. February 16 na class.
Okay, ako i-check, no? I thought I provided already all the recordings. So, alin naman na sa announcement ng ko ibutang.
Yes, sir. Or basin sa lahi ra to nga group class, sir, pero sa group 3 kay usa pa lang.
Usually nga na nako sa ibutang siya sa kuan blueprint ni ako lang i-share.
Okay.
Ako lang i-check, no? Ako lang i-check.
Yes, sir. Moasad, sir, if pwede may magpa-introduce to Mr. Mario De Leon.
Mr. Mario De Leon, no problem. Na siya sa De La Salle.
Yes, sir. Kay among problem ang good karon ni DM is sa data gyud kay dili mo hatag ang MCWD. So amo unta i-try to reach Mr. Mario De Leon mo ask me giunsa nila pagkuha og data nga natagaan sila.
Yeah,
Kay
ang akong gi-suggest if we could maka-visit dito sa kuan MCWD, no? Kay
yes, sir.
pareha ra man na sila
Na-
protocol, pero ang nakakuan is during the time of Engineer De Leon, lahi ang mga personalities diha sa MCWD kay dili man na sila permanente. Mga coterminous man sana sila sa mga politiko. So basically, mga yo ra gyud sa MC, no? So
yes, sir.
kung may magiun sa pagkuha, may maragay na si Engineer Dr. De Leon nga ito na nga ra gyud Miss MC. And by the time probably ang mga MCWD people are so accommodating.
Yes,
So
sir.
I suggest nga mo bisita gyud ta dito sa MC.
Yes, sir. Muason ta mi, sir, if na kay free time this month para maka-visit ta sa ilahang office.
Oh, na ko'y free time, no? Mga Monday o Friday.
Monday and Friday.
Monday, Friday. So mga ta sa 7th floor, that is the knowledge center of MCWD.
Yes, sir.
So, kana, and request ta nila unsay mga pamaagi nga maka-secure ta og data.
Yes, sir. Mo text lang minimo ni DM, sir, if kanus asad mi makalugar nga same sa imong schedule na free time.
Oh, basta ang akong free time is Monday
Monday
o
and Friday.
Friday.
Okay, sir. Noted, sir. Thank you.
Okay. So,
Hello, sir.
yes, Maria.
Our group, sir, baka we defended last February 19 and we sent, Godfrey Ruiz na sent an email to you, sir, of our revised paper.
Mm-hmm.
It's our topic, sir, is the incorporation of water hyacinth in concrete, sir. So we have revised na the paper, sir. So we
Okay,
hope, sir,
so gikuha naman ka to sa inyong advisor. Gi-endorse na to sa inyong advisor.
no sign pa, sir, pero we personally consulted Engineer Gitamondok after the defense, sir, and he suggested the new.
So, kung kadto na siya nga, di ba, gi-address naman to ninyo ang among mga comments, no?
Yes, sir.
Yeah, once makuha na to, so you ask first the endorsement of Engineer Gitamondok.
Okay, sir.
Okay.
We sent Engineer Gitamondok a revised paper, sir, pero no sign pa, sir. No feedback from him pa, sir.
So, kana, di man sab ko maka-act ana kung wala kay signature sa advisor.
Okay, sir. We'll email you back lang, sir, if nanay endorsement, sir.
Kuan na lang, no? So, kung nasa kay, of course, ang advisor magyud na mo endorse. Okay, unya human, i-email lang nako kung okay na, ha?
Ay, sir, pwede ma-ask lang, sir, if kana sakto ra among gibuhat, sir, ba?
Yeah, again, it either sakto siya or dili, but technically, di pa gyud ta maka-attach sa atong signature without the endorsement
Okay,
of
sir.
the advisor. So, kana i-discuss gyud sa inyong advisor kung mao ba gyud na ang atong i-pursue, no?
Yes, sir. We discussed it, sir, pero need lang on sign, sir. We will ask lang Engineer Gitamondok again to sign, sir.
Kay katong ang ilang sa katong usa ka group sab, ilang komisyo ba to?
Denmark, sir.
Sa ilang oropel, wa pa sa ko ni sign adto kay pag naaman ko'y ting na ko'y comment sa bato niya, wa pa sa to nila mabalik.
Okay, sir. Thank you, sir.
Sige. Napailaing concern? Okay na, Maria. So, magkuwat lang ko, Maria. Anyway, dili naman sab na siya nga urgent nga matter, no? Kay
Yes, sir. Para submission lang sa revised paper, sir, to Engineer
naka-enroll
ba?
sa thesis to, right?
Yes, sir.
So, dapat makaproceed naman mo sa inyong kuan implementation.
Yes, sir. We're doing it na, sir. We're preparing na the fiber, sir. Pero the other parts, sir, wala pa, sir.
Yeah. So,
Thank you, sir.
lang, anything that you can do already, kay certain na ta, agreehan na to, you can do it already. Pero, ang katong mga questionably pa nga part, so make sure nga you get the approval before you perform it.
Yes, sir.
Okay. Is that it?
Yes, sir. Thank you, sir.
Okay.